Good morning, Miss.
Hi, good morning. Could you please introduce yourself first before we start our session?
Sure. My name is Jajun and I am from University Malaysia Sabah.
So, hi, Jajun. So, I'm your interviewer for today. Before we start, I would like you to prepare some papers or your screen to answer some questions that will be asked to you later.
All right, Miss.
So, I can see you're interviewing for a computer science field. And in our interview today, I will be asking you some questions related to data structure, and it will be mainly about binary search tree. So, are you ready?
Yes, I'm ready.
All right, so my first question is, could you explain for me what data structure is and how it is useful in the computer applications?
Okay, in computer science, data structure can be defined as a format that is used to organize, process, and sort the data. And data structure is really important and it's useful as it helps to manage the large database and allow the computer to run it efficiently and smoothly.
Okay, good. Seems like you understand the question well. So could you give me some examples like where the data structures are applied in the apps nowadays? For example, like Google, Microsoft, or YouTube?
Let me use FB as an example. Facebook use graph data structure to organize their data. For example, the data of FB user, photos, video, and posts are represented by nodes, and each node will have edges that created relationship with other nodes, which are comments, text, friendship, and etc. So this is how the Facebook applies data structure.
All right, good. And I'll now ask you some questions regarding tree data structure. So similar to the graph data structure that you had mentioned just now, so the tree data structure has nodes and edges too. But of course, they are different from, which you can tell from the difference of structure of nodes. So here I'm going to present you a tree data structure on the screen. So take a look at the structure. I would like to ask you to insert some nodes for me into the structure. So is it okay?
Yes, Miss.
Okay, so now please open your whiteboard by clicking the share screen button below.
Yeah.
So, okay, so you can now see a binary search tree is presented on the left column of the whiteboard. Can you see it?
And yes, I can see it.
Okay, so my question is, please insert the nodes with data value 10 and data value 38, then delete the node with data value 32. Okay, so you may draw the structure on your paper or you can draw it on the right column of the whiteboard. Then please explain while drawing your structure.
All right. So can I start now?
Yeah, you can start.
So first, I will insert the value of 10 first. So at first, I will compare the value of 10 with the root node, which is the 26. So 10 is lesser than 26. So I will move to the left side. So to the left side, I will compare again with the value 16. So 10 is lesser than 16. So I will continue to move on the left side. I will compare to the value of 5. So value of 10 is greater than 5. So I will insert the value of 10 at the right side of the data of 5. This is my answer. So next, I will insert the value of 38. So as same as the previous one, I will compare the value of 38 with the value of 26. So 38 is greater than 26, so I will move to the left side. So I will compare again with 39. 38 is lesser than 39, so I will move to the left side. So I will compare again with the value of 32. So 38 is greater than 32, so I will move to the right side again. So I will compare with the value of 35. So 38 is greater than 35, so I will insert the number of 38 on the right side. Yeah. So I will write down all the rest notes.
Okay.
Okay, after this, I will delete the value of 32. So when I delete the value of 32, this 35 and 38 will automatically move to the upward. So I will try to draw. Yeah. So the value of 35 will move to the upwards, and the 38 is on the right side. This is my answer for the first question.
Okay, good. So you can stay on the whiteboard first, and please state all the binary search traversals for me, which you can see on the right side, right bottom column there. You can state your answer there, which you have to state all the binary search tree traversals of the diagram shown on the left side of the whiteboard. The traversals are in order, post order, and pre-order. So you may start now.
Okay, sure. So first, I'll go for the in order first. In order to write down all the nodes, I will start from the left side and then go to the root and then finally go to the right side. So I will write down my answer. First is the 5 from the left side, 16, 26, go to the root and then go to the right side, 29, 32, 35, 39, and lastly 57. So next I'll go to the post order. Post order is starting from the left side and then right and then lastly go to the root. So first I will write down the left side 5, 16, and go to the right 29, 35, 32, 57, and then 39. Lastly is the root 26. So for the pre-order, I will start from the root first, then go to the left, and finally go to the right. So first is the root 26, and then go to the left 16, 5, 39, go to the right 32, 29, 35, and 57. Yeah, that's all for my answer.
Okay, good. So now you may quit your whiteboard. And because for the next question, I would like you to prepare maybe papers or your screen to write down your answers for me. I need you to write a simple code for me on how to search the node from the binary search tree in Java. So you can start now.
So I will use my computer notepad to perform my coding.
Okay.
Okay. So, okay, first I will create a public node search the node. So the variable is the node root, and one more variable is the integer key, that the number we're going to search, the data we're going to search. So at first, if the root is equal to null, equal to null, or the root key is equal to key is equal to the number we go the data that we're going to search. So it will return roots. Else is the root key is lesser than the data we're going to search. So it will return search. Search on the, so if the root key is lesser than the data we're going to search, so it will go to the right side to search.
Okay.
So else we'll go to the left side search. Return search. The left side root, left and root, left. Yeah, that's all from my coding to search nodes.
Okay, good. Okay, I can see you understand tree data structure really well. So I would like to ask you to stop sharing your screen.
Yeah, sure.
So we are going to end our interview. So before you end our interview, do you have any questions?
I have a few questions here. And so as you mentioned earlier, graph and tree are quite different from the structure of nodes. I can see both data structure are non-linear data structure, but I'm something confused with the arrangement and the component of the nodes. Could you please explain more about this to me?
Okay, well, first of all, I can say the obvious difference between these two data structures is from the root node. So the presence of root node. So if you see there's root node, it means a tree data structure. Or if there's no any root node, that means graph data structure. And also you can tell the difference when there is loop between the nodes. When there is loop, it is the graph data structure. And also you can see when you compare the two data structures, the arrangement of nodes is hierarchical for tree, while network type for graph. So basically, there are some obvious differences between these two data structures in terms of like presence of root nodes, loops, and also the model type of the nodes, of the structure of nodes.
Okay, I see. So, and also tree data structure look less complex than the graph data structure. The tree data structure takes into account of the depth, while graph data structure doesn't. So, okay, now I can tell the difference already. So, thank you, Miss.
Okay, you're welcome.